Greetings, everyone. In this tutorial, we're going to go over a factorial ANOVA with a significant interaction using JASP version 19. So I'm going to share my screen with you here, and you'll see that I have a JASP data set. Um, I'm looking at sex differences between males and females using three different types of note-taking method. I have a control group that got no note-taking method, and then I have two different methods of note-taking method. Maybe one is an outline method, and number two is a narrative method. And we look at how much the GPA improved maybe over 2 semesters. So perhaps there was a measure of grade point average in the first 9 weeks. And then in the second 9 weeks, there's another measure of grade point average. And we subtract one from the other, and we have our grade point average improvement after being exposed to a note-taking method or being in a control group. So I always evaluate my model assumptions. You can do that by going to descriptive statistics, putting in your dependent variable, and then I would want to do this for note-taking method, and I might want to run a Shapiro-Wilk test and also look at some basic plots, such as a QQ plot or a customizable plot, such as a box plot. I'll want to do this same thing for gender. So instead of splitting my my uh, dependent variable by method, I would do it for gender and run the same analysis. So now I can look at my normality assumption, and with 20 in each group, I'd be interested in the Shapiro-Wilk statistic, and all these values are greater than 0.05, showing me a fairly normal distribution. Box plots and QQ plots can be a little more sensitive when your sample sizes are small. So I'm less concerned about these, but we do note that there are some outliers in the sample. For gender, I do kind of hit that 30 participant threshold in each group. So even though my Shapiro-Wilk is not significant for males, it is for females. So I do want to visualize this a little bit. And we can see that females is a little more positively skewed. There's not any outliers that are showing in my box plot. But we can see that there are some data points that are causing that skewness here. So usually ANOVA is robust to non-normality, particularly when our design is balanced. So notice I do have an equal number of participants in both groups here, as well as in my note-taking method section. So I do have a balanced design. Let's go ahead and continue with our factorial ANOVA. I'm going to put in grade point average improvement in my dependent variable, and my independent variables include gender and method. I'm going to scroll down. I'm going to hit to estimate descriptive statistics, estimates of effect size. I prefer the partial eta squared over omega squared, or eta squared here. I want my confidence intervals for my effect size. I'm going to click on my homogeneity of variance assumption. And let's just stop there and see what happens. After running my ANOVA, the first thing I want to look at is my interaction term. Actually, the first thing I want to look at is my assumption, my homogeneity variance assumption. And I have equal variances. This is not statistically significant. So now I can look at my ANOVA results. So let's do that. I got a little ahead of the game there, didn't I? Don't do that. All right. Model assumptions, then analysis. So let's look at our gender by method, and we see, oh, I do have a significant interaction. So you know what? I'm not even going to pay attention to my main effects now. We need to be focused on this interaction and see what's happening here. So I'm going to go over here, and I'm going to say simple main effects. And let's just say that I'm more interested in examining differences in method rather than gender. And so, whoops. And And so I'm going to look at my simple main effects. I also want to look at post hoc tests, should I have a significant result. And I want to note conditional comparisons. This is a new feature in JASP, but I'm going to click on effect size, conditional comparisons for interactions, and I'll show you what that's going to do. And I'm going to ask for my confidence intervals as well. So let's go and first look at our simple main effects before we look at our post hoc analysis. And we see that I don't have any statistically significant difference for males, but I do for females over note-taking method. All right. Well, what's happening here? I can actually graph that. I can go to uh, descriptive plots here, and I can say, make my method, my horizontal axis, and my gender in separate lines. And we can see, and I'm going to make this a little larger here to make it a little prettier. And we can see what's happening here. We can see that for males, which is the open circle, and the closed circle is women, but there's not a lot of change in males, but females, certainly there is change, with method 2 being the highest uh, grade point average improvement, and then method 1 in the control group not being very different. So this is why there's an interaction. Notice that my lines aren't parallel, but what's going on for males is very different than what's going on for females. For males, we don't see a lot of change in note-taking method or grade point average improvement across note-taking method. But for females, we do. So the question of is, does note-taking method matter? Depends. For males, not really. For females, it appears so. And we see that in our simple main effects when we see this significant simple main effect for women across note-taking method, but not so for males. So now we can look at our post hoc test. And remember when I hit that conditional option? Um, well, for some reason, it's not showing up. So let's take a look and make sure that I have that option available for post hoc test. Oh, I didn't put in my variables, so we want to do that. We want to run a post hoc test across my interaction term, looking at conditional comparisons for interactions. Doing a Tukey post hoc. And so let's take a look at what we've got here. Notice that for my post hoc comparisons, it shows me method 1 and method 2 and for men, and method 2 and control for men, and then it separates it for women. So the second comparison is comparing males to females across each method. I'm not interested in that. I'm more interested in this. I'm more interested in my note-taking methods being different, particularly for females, because that's where my simple effect was significant. And we can see over here that I do have a significant difference between method 1 and method 2, and I have a significant difference between the method 2 and control group, but not between method 1 and method 2. And here are my Cohen's D's and my confidence intervals for Cohen's D, that shows that. So going back to my diagram here, again, method 2 was different from method 1 and the control group, but method 1 and the control group weren't significantly different. And that makes sense from what I'm visualizing here. So that is how we analyze a factorial ANOVA with a significant interaction. I hope that helps.